A very good day, my dear postgraduate students. We shall be continuing with our classes on bone marrow aspiration. As I had been telling you people, it took me nearly 2 years to identify the cells, thanks to Professor Sethuram. In this class, I shall be continuing with the leukocytic series. We have already covered the myeloblast and the promyelocyte. Look at this one. So there is a pluripotent stem cell and it can be converted into a committed stem cell. The pluripotent can be differentiating into the lymphoid as well as the colony forming unit, granulocyte, erythroid, monocyte and megakaryocyte, GEM. So what happens over here is this has the potential to multiply and to divide into the monocyte, the neutrophil, as well as the basophil series, eosinophil, the megakaryocytes, as well as the erythroid series. At the other end, we have got the lymphocytes. So this is something that you people should always have in mind. So this is the basis for a stem cell leukemia. And in a case of chronic myeloid leukemia, why do you find all the cells? Because the defect is somewhere over here. Now, this is what is happening. In the humans, you find that there is a myelocyte. This is a diagrammatic one, a good picture. I find that the nucleus is slightly eccentric and there are the granules. From the promyelocyte downwards, you'll be finding the granules. The metamyelocyte, wherein there is a slight indentation, and the band form where it becomes C-shaped, and then there is progressive constriction where you get the matured cell. The hypersegmented is of course out of context in this. The myelocyte. So as I've been telling you people, there are the primary granules as well as the secondary granules. Primary granules are the eosinophilic granules and secondary will be more specific. Progressively you find from the myelocyte onwards, there will be a decrease in the primary granules and an increase in the secondary granules. Metamyelocyte, secondary becomes even more. Band form, even more. And finally, in the mature cell, it is 100% the secondary granules. The proportion gradually increases as the cell matures. And look at this myelocyte. Main thing I would like you people to appreciate it is got one edge of it is appearing almost flat and it is pushed towards the edge of the cell and it has got granules. The nucleolus is not very clear. So it is important. The only cell which will be having clear nucleoli as well as the granule will be the promyelocyte. This is of course the lymphocyte. And again a picture of it. A neutrophilic myelocyte, smaller than the promyelocyte, and it has got a more acidophilic cytoplasm. And here there is an admixture of the primary and secondary. The secondary granules gradually take over. So what I am trying to say you is I can have a eosinophilic myelocyte, basophilic myelocyte, or a neutrophilic myelocyte. The flattening and the oval contexture I have told you people. No nucleolus. And there is an indentation that you people see in a metamyelocyte. And finally, there is a C-shaped nucleus that you people see. The cytoplasm progressively becomes more and more acidophilic, courtesy American Society of Dermatology. This one I have explained already. I would like you people to kindly go through it. The myeloblast, the promyelocyte, as well as the other cells. Now, what you see over here, there is something that I would like you people to appreciate that is on the screen. Forget the text and the other things. I find that this is a large cell. The nucleus is towards the periphery and it has got some coarse granules which are somewhat similar to the RBC. So it is a eosinophilic myelocyte. And there is an indentation in the nucleus. There is a eosinophilic metamyelocyte. and it becomes a band form as well. So it is quite easy for us to make. And the author has picked up some neutrophils from somewhere else. So this is for comparison. Always the eosinophil you identify by means of the brick red granules and not the bilobed appearance. So there is a progressive decrease in the primary granules. This again, I would like you people to kindly follow this. I am repeating it. There is a multipotential hematopoietic stem cell, hemocytoblast. So this can differentiate into the lymphoid lineage or into the myeloid lineage. So here there is a common myeloid precursor from which I can get the megakaryocyte, the erythrocytes, the mast cell which is actually the basophil. There is a myeloblast. Then there is the basophil, neutrophil, eosinophil and this. Also there can be the macrophages. So see the potential of these. Again, what is your comment on this? I would like you people to kindly see that there are the granules. It is becoming more bluish. It is more eosinophilic here, whereas it is neutral in this case. So it is a basophilic myelocyte. Look at this one, an actual diagrammatic picture. There are coarse granules which are obscuring the nucleus. Same thing that you people see in the peripheral blood also. Coarse granules. So there is a eosinophilic myelocyte, neutrophilic metamyelocyte. That is exactly what we people are seeing over here. The myelocyte, peripheral nucleus, somewhere it is becoming flattened, admixture of primary and secondary granules. Here I am seeing more of the secondary granules. And neutrophil, obviously, there will be the secondary granules. A classical shift to the left, as we people can say. And you are seeing all these ones. Look at this one, a large cell with a large nucleus, prominent nucleoli, not much of granules, a blast. Here the granules are present, nucleoli. So it is a promyelocyte. And from these series also, here I am finding that there is granules present but not nucleoli. Here also so. So this is a metamyelocyte that I am seeing with an indentation. So kindly appreciate it. My question is, this kind of a picture, what does it resemble? It can resemble a picture of a chronic myeloid leukemia. So this is a series, and thanks to this, Rashidi and John, absolutely fantastic pictures. So the series follow this. So there is a progressive reduction, though actually the promyelocyte can be larger than the myeloblast. Prominent nucleoli, no granules. Nucleolus as well as primary granules. Admixture of primary and secondary granules, no nucleoli, no nucleoli, no nucleoli. There will be secondary granules that are seen towards the end. So this is something that we people will have to remember. Faith is taking the first step even when you don't see the whole staircase. That is exactly what you people should do. In hematology, if you people can identify cell by cell, then you have started learning the subject. And remember, even when there is a gathering of learned hematologists, there will be a difference of opinion among them, even regarding a particular cell. So we are not far apart from that. Thank you.